Okay, look at the data available. See, any of the things can be asked. You have to be very careful. Q positive, Q negative. A proton is bombarded on a stationary lithium atom. There's a proton. As there are two alpha particles. Directions making an angle theta, where cos theta equal to 1/4. Find the kinetic energy of the striking proton given binding energies per nucleon. I think we should first calculate the Q. Q positive or negative. See, once you get Q positive, then you can justify why alpha particles are deflecting like that only. Q is equal to mass of parent. So this will be binding energy. Lithium, how many will be there? Okay. Helium, no? Okay, 7 will be there, no? So 7 into 5.6. Minus, so helium there are 2 into 4 into, then binding energy per nucleon, 5.6 mega electron volt. Look at the value of Q.
Sir, it should be binding energy of daughter minus parent, no, sir?
Oh, masses given, no? Binding energy. Yeah. I thought masses. Okay, I'll change it. Yeah. No, I thought masses, that one. No. Okay, so thanks for correction. You look at this binding energy of this is a daughter minus binding energy of parent. Things have changed a little bit, so I'll write it here. Binding energy of daughter. I made correction. Yeah. Okay, this is it. So when the binding energies are given, binding energy of daughter minus this one. So this Q will be in anybody value?
17.28, sir.
17.28. Okay, now how the reaction we should write in kinetic energy of the proton plus don't write mod. Okay, if you have a practice of writing, okay, leave it. Anyway, Q is positive only. So this should be equal to 2 times of K alpha. So what is the problem here? We don't know K alpha. We have only Q. Kp and K alpha are unknown things. Apply conservation of linear momentum. 2 times mpk alpha should be equal to 2 times of.
Sir, that is 18 to 7.06, sir.
Yes, sir.
You wrote 5.6.
Which one?
In the equation of Q, 2 into 4
Binding
into
energy of
7.06.
daughter.
Binding energy of daughter.
It's not 5.6, sir. It is 7.06.
7.06. Okay, this one. The helium, no? 2 into 4 into 7.06. Still answer will come same.
Correct, sir. Correct. Answer is correct, sir.
Answer is correct.
17.28.
Okay, then. Yeah. This is 2 m alpha k alpha cos theta. Cos theta is given. So kp k alpha, 2 equations, 2 unknown. So now you get an exact picture like if Q positive in the energy mass equation, kinetic energy plus Q equal to the kinetic energy of incident particle plus kinetic energy, the energy available due to reaction plus kinetic energy of the products. If Q negative, put mod Q in the RHS, or else open any equation, write it, substitute Q with sign. Problem solved. Anything you write it, kinetic energy of incident particle plus energy available for the reaction or energy required for the reaction, substitute here equal to kinetic energy of products. So substitute that energy. If they're positive, okay, let it be here. If they're negative, okay, let it be here. Substitute with sign. Or energy requirements, okay, I told mod of Q because I wanted to tell you that the incident particle will supply energy for the reaction to occur, and also it will give kinetic energy to the products. So for that purpose, I wrote mod of Q. So here open energy available due to reaction plus kinetic energy supplied. Both are available as kinetic energy of products. Try to interpret this equation, very important. The rest all momentum equation, you know, don't go for velocity here. I don't know, students still they do mistake here. They'll assume velocity, you not. I think you're in a big trouble. Everything right expressed in terms of kinetic energy. So this equation is very important. Once you are correct this, you know already in collision, you are quite familiar. Sometimes these two may not be particles. In that case, what happen? You know momentum of this, you know momentum of this. I think you can express kinetic energies. Total momentum should be conserved, no? So you can write in vector form. There you may get a question